Hello, Matrix, and welcome again. Today we are looking at optimization, which is a big, scary word, but you don't need to be worried about this because it's the same type of questions each time, but they disguised a little bit. So you just need to be able to follow the steps and not panic when you see something which is a little bit different. Okay, so I've got a question here, which is not from a past paper, but it's a classic optimization question. So an optimization question, you need to look for things like find the maximum and find the minimum. Okay, so what I've done is I've put 4 easy steps that you just follow when you get to one of these questions. So let's look at the question first. So it says, the profit earned by a company manufacturing X bicycles per week is given by a function h of x equals, and then there's the function in terms of bicycles per week. It says, what is the maximum profit? So this is why calculus is so great, because we can find profit maximization, which is obviously used a lot in if you ever do finance or economics. So what we do is we follow our steps. So the first step is often already done for you, which says get the function in terms of one variable. So as I said, if you watched any of the other optimization videos that I've done, and I'll do a few so that we can get used to the different types of questions, a function could be f of x equals something, something, something. And as long as it's in terms of just x, it's already in terms of one variable. Here, we've got h of x. So it's labeled a bit differently, but of course, it's still just a function in terms of x. And we do only have one variable x. So it's step 1 is already done in this question. So I'll do another question, which where you'll have to get it in terms of one variable, but for now, step 1 is already done. Then it says find the derivative of the function. So when you get to these optimization maximum questions, when in doubt, find the derivative. So even if it doesn't say find the derivative, we know we need to do that, because when you find the derivative, that's the first step to finding the maximum or the minimum. So let's find the derivative. So h of x equals negative, and instead of saying x cubed over 150, I'm going to say negative 1 over 150 x cubed, because that is what is the same thing. And then I'm going to say 3x squared minus 250x minus 2700. Now I find the derivative. I'm doing step 2, which is find the derivative. Okay, so nothing out of the ordinary. 3 times minus 1 over 150 is minus 3 over 150 x squared, plus 6x, because 2 times 3 is 6, minus 250. Okay, now what I need to do, step 2 is done, is make it equal to 0. So I'm going to do that. Make it equal to 0. And so I get 0 equals this long function here. X squared plus 6x minus 250. Okay, so now what I want to do, it's a little bit complicated. So this 3 over 150 is actually the same as 1 over 50. So I'm going to make it 1 over 50. And if I times that by minus 50, if I times everything by minus 50, that's going to at least get me my x squared, because negative 1 over 50 times 50 is just x squared, and then it's going to be minus 6 times minus 50, 300, and 250 times 50 is going to be 25 times 50 is 1250, as well 12,500 positive. 12,500. Okay, now there's, this is a x here, 300x. Okay, so there's a few ways of solving this. I've actually got a video on how to solve these quadratic equations using either your silver calculator, quadratic formula, or just the regular way. I think for this, I'm just going to use the quadratic formula, because I'm not going to assume that everyone has a silver calculator, but if you do have a silver calculator, this question becomes much easier. Okay, but we don't need it. You can't blame the tools if you don't have one. It's fine. Negative b, right, is going to be, okay, well, let's just, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac. And this is what you use to solve an x squared equation, all over 2a. This is in the back of the exam sheet, so you'll be able to get it there. And this is going to be negative b, so it's going to be 300, because negative times negative is positive, plus or minus the square root of now b squared is going to be minus 300 squared, minus 4a is 1, and c is 12,500, all over 2 times by, and even if you use your silver calculator, you still have to put this in. Okay, and then we get our calculators and we put that into our calculator. Okay, so we put it into our calculator. I've not got the calculator app on my screen like I normally do, but as I said, I'll put a link in now to the video where I show you how to do this with a calculator. But this, we just put it into our calculator, and we should all know how to do that, and we get 250. Or, and when we try that, that's when you put in plus, and then if I put it into negative, delete, minus, I get 50. So it's x equals 250 or x equals 50. Okay, so that is done. And now what I do is I substitute this into the substitute into the original equation. That is my step 4. So I'm going to try h of 250 first. And I'm going to put it in here. So it's minus, and then it's going to be 250 cubed over 150 plus 3, 250 squared. Now, there is an easier way to know which of these is the maximum and which is the minimum. And I could do that by finding my point of inflection, like we did in a cubic graph. But I want to simplify this as much as I can for you guys. And if you want to look at how to know which is the maximum, which is the minimum, you can check out one of my videos. But just briefly, if I see that this is negative x cubed, right? That means that x cubed, when x is say negative 1 million, negative 1 million times negative 1 million is become a negative, but then it's a negative in front. So as I tend to negative infinity, I actually get a positive value. So I'm going to get this because also, like, say I have positive 1 million. So positive 1 million cubed is a very big number cubed. So as I go this way, there's a negative in front. So I end up, as I go from as x goes to positive infinity, it ends up going down. So I know that my value is actually going to be 50. Sorry, 250. So I already know that it's 250, but I'm going to, in case you don't know how to do this, I'm going to just do them both. And so this is going to be the one that gives me the biggest number, but we can still check and into our calculator, and we get 18,133 Rand and 33 cents. Okay, we don't know that it's in Rand, so I'm just going to say 1833, although we are in South Africa, so let's put a Rand in there. Okay, and then we can try 50. And so, as I say, not too thing, but I put the 50 in wherever I had a 250. So if you can see there, 250, I need to change to 50. 2,700, I need to change this to 50 as well. And finally 50 cubed. And this should be lower than the other one, and of course it is. It's minus 8533. So I know that this is my maximum here. And I knew that it was going to be 250 because 50 was here and 250 was there. Because if this was my function here, we had 50 and then this would be 250 over there. Okay, so there were just the 4 simple steps that we needed to follow. One was already done for us. Then we find the derivative, which was done here, right? That was step 2. Step 1 was already done. And then step 3, make it equal to 0. That was done there. And then we got values of 250 and 50. That is substituted back into the original function, which is the function that they give you at the very beginning, or maybe you have to work it out. And that 250 goes in there. So you put a 250 in there. And you get your final answer. And this is going to hopefully be 6 to 7 to 8 simple marks in your final matric exam. So I'm going to do a couple more of these, but all you need to do is don't panic, follow the steps. So if you look at it and it looks Greek to you, don't worry, just follow the steps. So you're going to do a few more of these. So please find the link below, and you need to subscribe. My audio visual thing has been messing up all day. I don't know what just happened there, but yeah, find the subscribe button, like, share with all your good friends, and I will see you soon for another optimization question.